Good evening, good morning, good afternoon. This is Statistical and Geospatial Inside YouTube. We are meeting in lesson number 28, which is about calculation of confidence level. By the end of this lesson, you will be able to calculate confidence level manually using the Z-score method. In lesson number 27, we had discussed about the most important concept used to define the confidence level and the importance of confidence level. Today, we're going to see how to calculate the confidence level using the Z-score method. The question is, why learning calculating confidence level manually is very important, although statistical software can do that. The answer is that once uh, you have been able to calculate the confidence level manually, as you practice doing this calculation, you will grasp the concept of the uh, confidence level. And this will enable you to prevent some of the common misunderstanding about the confidence level. For example, you may assume that uh, a 95% confidence interval means there is a 95% probability that the true parameter is within that specific interval. No, this is wrong. Uh, the meaning of the 95% confidence interval means that if you repeated the sampling process many times, about 95% of the intervals created would contain the true population parameter, reflecting the reliability of the method, but not a probability for a single interval. The second reason why learning calculating confidence level manual is very important is the interpretation of the software output. That is because once you have mastered how to calculate the CL manually, you will have equipped yourself with some knowledge of how to interpret the software's output correctly, and also it will enable you to assess the reliability and precision of the estimates. The third reason is about informed decision making, because making decision on the right statistical method and confidence level for a given situation. And also, you'll be able to recognize factors like sample size and data distribution and data disturbance. The fourth reason why learning calculating CL manually is very important is that you'll be able to deal with the troubleshooting and error detection. You'll be able to spot potential errors in data entry or computational errors within the software itself. The fifth reason is handling the non-standard cases. Software can only handle most standard scenarios, but cannot handle complex or unique research designs that might require customized approaches or the use of specific formula not immediately available in the basic software packet. Therefore, having learned how to calculate the confidence level manually, you'll get some knowledge of how you'll be able to deal with things such as handling the non-standard cases, which the software itself cannot do with it or cannot deal with it. The last is about foundational skills for advanced study. Manual statistical calculation is a prerequisite for advanced statistics courses, machine learning, and data science. To deepen our understanding of the calculation, let us look at the following example. A study measured the systolic blood pressure of 82 randomly selected divers who are over 45 years old. Calculate the 95% confidence interval for the true mean systolic blood pressure of the entire population of divers who were over 45 of years. The sample mean was 128 millimeter of mercury with a standard deviation of 4.8 millimeter of mercury. Solution. First of all, you write down your data. The sample mean is given, the sample standard deviation is given, the sample size is given. And what is needed here is that what is the corresponding Z value for a 95% confidence level. So to get this corresponding Z value, we're going to find it from the Z distribution table. So in the table here, this is the table. You go and look for 95%, which is 0.95. So this is here you have your 0.950. This is 95%. And this 95% does correspond to a Z value of 1.6. Again, you go upward. You go upward for this column here, you'll find a probability of 0.05. And then you're going to add this 0.05 to 1.6. Then you'll have 1.65. So having added the 0.05, then you will get the corresponding Z value for the 95% confidence level is 1.65. Here, the second step is to calculate the standard error, this one. The standard error is given by the standard deviation over the root of the sample. When you carry out this process, you'll get 0.53. Then you calculate the margin of error. The margin of error is given by the standard error multiplied by your Z value. So when you multiply 1.65 times 0.53, you'll get 0.87. So this is your margin, the margin of error. Now, the lower limit here is the sample mean minus the margin of error, 128 minus 0.87. You'll get roughly 1.27 millimeter of mercury. The upper limit is given by the sample mean plus the margin of error. You'll get 128 plus 0.87. Roughly, you will get 1.29 millimeter of mercury. Interpretation. The physician can be 95% confident that the true population mean falls within the range. This interval indicates how precise the estimate is based on the sample data. The 95% confidence interval for the true mean systolic blood pressure is 127 to 128. You can realize here that 128 falls between 127 and 129. Thank you. Please subscribe to the YouTube channel.